Sir, am I audible?
Yeah, audible.
Sir, am I audible?
Yes, you are audible. So how many are the bio teacher is taking the class? Hello? Hello, Sanoy? Hello? Your what the sound that is you are the silent now. You muted yourself.
Okay, I'm joining 1 second.
No. You are muted, yaar. You just remove that one. You click on that mic one.
Sir, I have already left the meeting, sir. How I can do it?
Now, but okay. But here it is showing you are there in the meeting.
No, sir, why do something? I don't know, sir. I left the meeting, sir. I don't know how.
You maybe join with the two device then.
Yes,
So one device is that device is muted one.
okay. Might be problem, sir. Might be problem.
Now it is okay. Now the check that one. Now you join. Join.
I already left the meeting, sir. I shut down the device also, sir. How I can check that?
Okay. Now you are joining now. You will check.
I joined now.
Hello.
Sir, am I audible now?
Audible. What is the problem, sir? No? Why we are facing the problem? Audio.
Don't know, sir. Sir, actually, the device I was using, that is a very old device, a 17 years old laptop. There might be some issues in that one, so they're not here.
Mm-hmm. Okay, no problem.
Sir, old device means sometimes it malfunctions.
Okay, see the questions. Okay, first of all, you write. We are having RMGX, and here is H, C double bond O. This is H. What will be the A? Then the A is hydrolyzing, so it is going to give B. Second reaction, we are having RMGX. It is reacting with CH3 C double bond O and H, plus it is giving A again, which is on hydrolyzing H O H, it is giving B. The last one R MgX plus this one is CH3 C double bond O, this is CH3, then it is giving A, and here is anhydrolizing HOH, it is giving B. Very good. Keep on writing. Okay. Hmm. So this is the correct one. Can you write the another one?
Yes, sir. Trying
Hmm.
out, sir. The structure is stage 3, C double bond O H, RMGX.
Second one, you are not doing, you are taking too much time.
Doing, sir. Doing. CH.
Hmm. Correct. Okay. Next. This is correct. Can you write the next one? The product we are writing, that is wrong. How you can write the product? This is you have to start from here downside.
One
So
second.
downside you are starting, that is R. This will be C. Upside CH3, downside CH3, and then it will give OH. 3-degree alcohol. Okay, don't waste the time, and that is enough. Okay, so from the yesterday I told you from the reduction of carbonyl compound. Okay, so by the reduction of carbonyl compound, you can also prepare what? Alcohol. Because what the carbonyl compound you can see here, the carbonyl compound is what from, suppose I am taking the one aldehyde, from aldehyde. Up to reduce the aldehyde, what the reagent you can use? Here you can use the, whether you can reach the NaBH4. This is the sodium borohydride, or you can use the LiAlH4. This is lithium aluminum hydride, or even you can use NiH2Ni. H2, this will be Ni, hydrogenating catalytic, Ni, or PT or PD. These are the catalyst can be used. Getting? So what it is going to give? Any of the catalyst. So if you are using this one, it is going to give the alcohol. So the first reaction, suppose you are having RCHO. This is there. And you are, this is all is having the hydrogen. And I am taking the PT or PD or Ni. So what it is going to happen? This hydrogen will be going here. So it will give RCH2 and this will become OH. So that is 1-degree alcohol is going to form. If you are taking the same one, suppose RCHO, and here if you are taking this one NaBH4, NaBH4, or you can take LiAlH4. So here you can see in the this one, what are these? Are the excess hydrogen are there? One molecule of sodium borohydride is having 4 molecule, yeah, 4 atom of what? 4 mole of hydrogen. So this hydrogen will be going here. So what it will be give? RCH2, and this will give the OH. 1-degree alcohol. Another reaction you see. Suppose you are taking the ketone RC double bond O. This is the R, and if you are taking the same one NaBH4. So what will it is going to give? This will go one hydrogen here, one hydrogen here. So you can see this is R, this will be CH, here will be OH, this is the R. So this is going to be 2-degree alcohol. So aldehyde give 1-degree alcohol and ketone give 2-degree alcohol. Can you understand this?
Sir, all this the reaction will come, sir, in the exam.
Why you need not to memorize?
Done.
Any reducing agent you can use, Ni, H2Ni, PT or PD. Anything you can use out of this all. Getting my point?
Got it. Got it.
Uh, Up next one is there. By reduction of carboxylic acid. By reduction of carboxylic acid. By reduction of carboxylic acid. So if you reduce the carboxylic acid, then you will get the alcohol with only. Here you are saying carboxylic acid can be reduced into alcohol by a strong reducing agent such as you have to take such as LiAlH4. This one only can be used. Okay. So suppose we are having R, C double bond O, here is OH. And then you are using the LiAlH4, lithium aluminum hydride. This is the strong reducing agent, LiAlH4. What it is going to happen? So two hydrogen is going to attack here and two hydrogen going to be there. So it is going to give RCH2OH plus water will be out, plus water. This is 1 degree alcohol. Note, LiAlH4 is costly. LiAlH4 is costly catalyst. So carboxylic acid, they are saying carboxylic acid firstly converted into what you are going to converted into ester, ester, okay, by esterification you study in the 10th standard also, esterification. Then it can be reduced easily by what? H2PT or H2PD or H2Ni. So this is there. So first of all, see if you are having carboxylic acid, R C double OH plus alcohol we have to take. Okay. From the acid, what it is going to out OH and from the alcohol H. This reaction is called esterification. H plus required. This is esterification. Esterification. So what is happening? Minus water is removed. R C double O R. Now what we have to do? We have to take the H2 PT. So here it is going to be, here H2 will go and this will be splitting out here. So what is going to give? Two type of alcohol will come out. So one alcohol is RCH2OH1 and another is ROH. One alcohol is having more carbon, another is having less carbon. Can't you understand this?
Yes. Done, sir. Done.
Okay, this is method of preparation is over. Now we are going for what? That is physical properties of alcohol. Physical properties of alcohol. Physical properties of alcohol. The first point which you are going to understand, boiling point. Boiling point. Due to presence of intermolecular hydrogen bonding, strong intermolecular hydrogen bonding, its boiling point. Better you can use the word their boiling point. Their boiling point are higher than ether and hydrocarbon. Hydrocarbon of comparable molecular mass. Comparable molecular mass. So now you see here what we can do here. Suppose you can take the CH3, CH2OH. Its molar mass is how much? 46 Kelvin. And boiling point is 351 Kelvin. Now you can see the ether. CH3O, CH3. This is there. Its molar mass is how much? Again 46. 46 Kelvin. But you see the boiling point. Boiling point is 248 Kelvin. Reduced. Then you can see the propane. CH3, CH2, CH3. Molar mass is going to be 44. Around the same. But boiling point 231. So because why the boiling point decreasing? Strength of what? Strength of H bond decreases. H bond decreases. So boiling point decreases. So boiling point decreases. So these were the first point. Second point. Boiling point proportional to molecular mass. Okay. So boiling point proportional to molecular mass. So if molecular mass increases, then van der Waals force of attraction also increases. As a result, boiling point increases. So if you are talking about that is CH3OH, CH3, CH2OH, Then what we can write CH3, CH2, CH2OH. So boiling point is going to increase. Increasing order of boiling point. As molecular mass increases. So if you increase the molecular mass, force of van der Waals force of attraction will increase. So what will happen? Boiling point will increase. Third point, of same molecular mass, of same molecular mass, of same molecular mass, what is happening, of same molecular mass, boiling point decreases, boiling point decreases with branching, with branching. As unbranching, what is happening? As unbranching, surface area decreases. As unbranching, surface area decreases. So surface area decrease. So means boiling point will be less only. So if I will write the boiling point of isomeric alcohol, we are having the highest boiling point will be this one. CH3, CH2, CH2, OH. This is an N-pentane high boiling point. Then you can make the branch here. CH3, CH, here is CH3, then CH2 and OH. And lastly, you make the two branch CH3, C, here is CH3, this is CH3, this is OH. So what is there? Decreasing order of boiling point.
Sir, on branching, surface area will increase or decrease, sir?
Decrease, here it will become a smaller molecule now. See, the surface area is how much? Large. Surface area means what? The surface it is covering. Suppose you are boiling, you are having glass of water, and you are taking this one, the first molecule. It is covering this much area. Second molecule, it is covering this much area. So which one is having the more surface area? The straight molecule, unbranched molecule, more surface area. Unbranching surface area decreases.
Got it.
Done.
Understood.
Done. Okay,
Yes.
thank you. To due to formation of H bond with water molecule, H bond with H2O molecules, they are soluble in water. They are soluble in water. They are soluble in water. Note, the solubility decreases, solubility decreases on increasing, the size of alkyl group. If alkyl group is larger size, so its solubility will decrease. Suppose we are having CH3OH, this is more soluble compared to CH3, CH2OH, ethanol, then compared to propanol. So if you are talking about the size of alkyl group increasing this size, so solubility is decreased. So decreasing order of solubility. Can you understand this?
Understanding, sir.
Hmm.
Writing, sir. You give me some time for writing. Because, sir,
Okay,
if
okay.
I tell I go to writing next time, sir, then there's this problem, sir. Afterwards, I don't remember.
Hmm.
Then scroll a little bit upward. Upward. Okay, then. Thanks.
Done. So we have to, this is the physical properties method of preparation. All we finished out. Now we have to go for the chemical properties. Right. So chemical properties can be of many types are there. Right. Let us see the chemical properties I am writing. Chemical properties of alcohol. Chemical properties of alcohol. There are two ways the reaction takes place, Sanay. Okay. What the reaction case one is there? Case one. When OH bond break. When OH bond breaks. When OH bond breaks. Either you write in the when OH bond breaks. That is, here I am writing the statement. What the statement is there? When alcohol react, act like the nucleophile. When alcohol act like nucleophile, the OH bond breaks. The OH bond breaks. Now you see, suppose I am having ROH. Here, this is the compound is there. You can treat with the any attack on the any of the carbocation. This is positive charge. So this nucleophile attack here. So what it is going to happen? So firstly, it is going to form the intermediate. Let me write this intermediate. So R we can write, R is attacking from the bottom, so it is the R will be downside. It is getting added with the O, that is correct. Then O is joining with the C, and this C and this is like the, and this is having the positive, this hydrogen is also there. So here will be the positive charge. Till now bond does not break. In the final state, what will happen? In the final state, OH bond is going to break. So this bond, a little bit difficult you will find until or unless you study the reaction on it. So now the next step, this is going to neutralize this one. So H plus is going to out. So R, O, then here C, this is there. Plus H plus is out. So when it is acting as a nucleophile, so this is what the compound is forming. This compound is ether. So first of all, we are going to do the problem on it. When it is acting as a nucleophile, that we are going to study.
Sir, I'm still writing this. Sir.
Right, there is no problem. So in this reaction, which bond is be splitting? This bond is splitting. OH. The first one reaction we have when OH bond breaks. The first one reaction with metal. You see reaction with metal. Reaction with metal. So if you treat the alcohol with the metal ROH, you are taking two molecule and treating with the sodium metal. So what will happen here in this case? Hydrogen gas will be out. So it will be 2RONA plus hydrogen gas. This is what is called alkoxide, sodium alkoxide. One day you ask what is the name of this one. This is what is sodium alkoxide. Sodium alkoxide. Now you see, if I will take CH3OH and treating with the sodium metal, take the two molecule, so H2 gas will be out. So what will be happening here? This hydrogen will be out, two hydrogen. So hydrogen gas, and then you are writing 2CH3ONA. Its name is sodium methoxide. Its name is sodium methoxide. Can't you understand? Hello?
Sorry, sir, mic was mute.
Uh-huh.
Understanding.
Okay.
H2.
Reaction with aluminum. This is very simple reaction. Alcohols are little slightly acidic if you consider to be acidic or basic in nature. Acid base both react with what? They are react with metal, so release the hydrogen gas. Whether acid is there or base is there, they react with metal, so they release hydrogen gas only, no other. So they are releasing the hydrogen gas, and simultaneously that is the salt is going to be formed. This is there. Now reaction with aluminum, which one we are talking here? You see six molecule they have taken. CH3, CH3. Here is CH3. This is OH. If I will write this is minus, this is plus. So valency of this compound is, I will write this one, valency is how much? Valency is 1. And if I am treating with the 2Al, its valency is how much? Valency will be 3. Valency is 3. So how it is the cross multiply if you are writing? So this one CH3C, this is going to be CH3, this is CH3, here is O, this is going to be 3 times with Al, plus 3H2 is going to be out. This is if you are writing, so what we can write? Aluminum, this is the tributoxide. Done.
So product side I'm writing product side.
Mhm.
Done.
Next one is there esterification reaction. Esterification reaction. If I will write the esterification reaction based on this one, esterification, in which bond is going to break? In the esterification reaction, OH bond is, because we are studying the reaction in which OH bond gets break. So OH bond will going to break. Suppose we are having, first of all, the mechanism is not there, but I am explaining the mechanism. You just little bit you try to understand what we are having. We are having ROH. Then we are having suppose acetic acid we are writing the carboxylic acid R, C double bond O, and here is OH. So what is there is lone pair electron. So this lone pair electron is attacking here, this bond is shifting. So what is going to happen in this case? So R is there, this is C, this is O minus, here is OH is there. Downside, which one is getting at? This is OH, and here is R. This is positive charge. Final state you see. In this case, the finally what will happen? This bond is shifting here. So once this bond is shift here, means this has to go out. So wait, now
Yes.
bond is splitting. That is OH bond has to split, na. This is the mechanism. I just here this is there. That is no problem at all. Up to here there is no problem. Here is O is there. O. So which bond is splitting? This bond is splitting here. This is O. So see the compound now. How we are writing? So we are writing the upper part like that. R C double bond O. This is the O. Not correct. R C double. It's not going to be correct one. So taking there is no problem at all. This bond is breaking also correct one. Leave it Sanay. This one is not getting plus. I'll tell you the mechanism. Mechanism not there, by the way, not there in syllabus. So here in this case, that is only the OH bond breaks. Here is water release. Actually, generally they ask that is uh, from what the OH will release and on what H will release. So this is the reaction, esterification reaction is what in which the hydrogen of OH group OH bond break and OH group of acid remove. So it will give R C double O R plus it will give H2O. This is what is the ester. Another example you see, if I will
Writing
take
the
ROH I am taking, and one more we are taking acid chloride, R C double bond O and Cl. So in this case, again this bond is going to break, OH bond. So HCl is going to out, HCl. And the product will be remain the same, R C double O R. It will take little bit time to understand for all the reaction. If suppose ROH is there and you are treating with the acetic anhydride CH3, C double bond O, then it is O, C double bond O, and here is CH3. So what it is going to happen, you see, here it is going to split out, here, this one. So what is going to happen here, and this bond is going to split like that, this bond. So if it is splitting, so you see this, what the product is going to form. CH3, C double O R. This is there. And one molecule of acetic acid will form. Again, in each case, what is there? This is the ester only. In each case, ester is forming. One more reaction is there, that is called aspirin. Out of this all the reaction, the other reaction asked in the exam. What is there? Let me tell you this one. This is, when we will study phenol, this will again come. This is called salicylic acid. SALICYLIC. This is salicylic acid. And if you treat this salicylic acid with acetic anhydride, then what will happen? The similar reaction, CH3, C double bond O, this is O, C double bond O, CH3. How we generally write this reaction, this compound, CH3, CO, whole twice, and this is O. Now, see the important product, what the product is going to obtain here. The same way this hydrogen, the same way this hydrogen I'm combining with this portion. So acid is formed. Another one compound you see, another compound. Which one is important one? C double OH. Here is O. This is C double bond O. This is CH3. And another compound is CH3 C double OH. This compound is called aspirin. ASPRIN. Aspirin. Aspirin and dispirin, they are two compounds which are the painkiller. And if you are writing this one, acetyl salicylic acid. This is acetyl salicylic acid. There are many reactions, you must be getting confused, but you read once the NCERT book. This reaction is very important that you memorize. Hello.
Yes, sir.
This reaction you memorize, this reaction. Salicylic acid having OH group react with acetic anhydride. This reaction is also called esterification only. Esterification, because ester is getting formed. Then it give the aspirin plus acetic acid. Now in the evening time we will study reaction due to
Sir, in the
C
afternoon when you will take the class, sir, you did not tell me yesterday.
afternoon. I'm not getting time now. Not being possible, and I don't think it will be. It will be more hectic for you only to
Sir,
understand.
nothing is hectic for me, sir. I am able to join.
You are able to join. Otherwise, you can continue then. Now only. Also, time is there.
No, sir.
Other,
Instead of this continuous one, if we get some afterwards, then it would be a break. Now, otherwise, sir, I am also doing the online class right from the morning, sir, from 10 a.m.
oh. Okay. Can you join 5 to 6 then?
5 to 6?
No,
5
6 to 7. 6 to 7. 6 to 7.
6 to 7, yes. I can join 6 to 7.
6 to 7 you join. Today, the girls are not coming. So 6 to 7 you can join.
Sir, after that, can you, after this class, can you send me the notes, sir, these notes?
These notes I will share. 6 to
Okay.
7 you join, and then night time 11 o'clock or 10 o'clock.
Okay.
Then probably this alcohol will be over. And once alcohol will be over, we will go for the phenol. Phenol over, then one class will be for the ether. So four more class, this chapter will be over.
Okay.
Uh,
Okay.
okay, okay, take rest little bit. You join 6 o'clock.
Sir, can
Before
you put me
time,
these slides right
uh,
on my? Hmm.
slides, wait, I'll sharing you now only.
Okay. Okay.
Okay, I'm sharing right now only. It is taking a little bit time.
Okay.
Hmm.